8th grade, Unit 5, Lesson 6, Even More Graphs of Functions. Problem number 1. Match the graph to the following situations. You can use a graph multiple times. For each match, name the possible independent and dependent variables and how you would label the axes. For graph A, the starting point is greater than 0, and graph A shows increasing at a constant rate. Graph B has a starting point also greater than 0, and graph B shows the same amount decreasing. And finally, graph C has a starting point that's greater than 0, and graph C shows an amount decreasing. A. Tyler pours the same amount of milk from a bottle every morning. That will match up with graph B. As you can see, each morning Tyler is pouring the same amount of milk, and the amount of milk in the bottle is decreasing as the days increase. B. A plant grows the same amount every week. That matches graph A. As you can see, the starting point of the graph is the size of the plant when it was planted, and then each week it grows at a constant rate. C. The day started very warm, but then it got colder. This matches with graph C. As you can see, graph C starts with a very warm temperature. The temperature decreases as the time of day increases. D. A carnival has an entry fee of $5 and tickets for rides cost $1 each. This situation matches graph A. The y-intercept represents the $5 entry fee, and its positive slope represents the money spent on rides. Problem number 2. Jada fills her aquarium with water. The graph shows the height of the water in centimeters in the aquarium as a function of time and minutes. Invent a story of how Jada fills the aquarium that fits the graph. First, she turns on the water and fills the tank for 2 minutes. Jada stops to rest for 1 minute. Then Jada resumes filling the tank for another 2 minutes. Then she drains out some water for 2 minutes. For the next 3 minutes, she doesn't add or remove any water. Problem number 3 from 8th grade, Unit 5, Lesson 4. Recall the formula for area of a circle. The area of a circle is pi times the radius squared. A. Write an equation relating a circle's radius r and the area A. A equals pi r squared. B. Is area a function of the radius? Yes. Is radius a function of the area? Yes. C. Fill in the missing parts of the table. Let's start with the formula A equals pi r squared. We can substitute the r, or the radius, with a 3. Since the table has a 3 for the radius, well, the radius squared would mean 3 squared, and 3 times 3 equals 9. The area would be 9 times pi, or 9 pi. Let's look at the next column in the table. This time they don't give us a radius, but they give us the area, and the area is 16 times pi. We have to ask ourselves, what radius times itself would equal 16? And that would be 4. Since 4 times 4 equals 16, we know that the radius is 4. Let's look at the next column in the table. The radius is 1/2. Since the area equals pi times radius squared, we can substitute the 1/2 for the radius, or substitute the 1/2 for r. Now it reads area equals pi times half times a half. Since half of a half is a fourth, the area equals pi times 1/4, or 1/4 pi. And finally, let's look at the last column in the table, where the area is equal to 100 times pi, or 100 pi. So we have to ask ourselves, what could the radius be if the radius squared, or the radius times the radius, equals 100? That would have to be 10, because 10 times 10 equals 100. When the area of a circle is 100 times pi, then its radius is 10. Problem number 4 from 8th grade, Unit 3, Lesson 11. The points with coordinates 4 and 8, 2 and 10, and 5 and 7 all lie on the line 2x plus 2y equals 24. A. Create a graph, plot the points, and sketch the line. First, let's make a graph, and now we can plot the various points. 4 and 8, 2 and 10, and 5 and 7. Now we can sketch the line by drawing the line through these 3 points. B. What is the slope of the line you graphed? Down 2 and to the right 2. So that's negative 2 over positive 2, which is equal to negative 1. The slope of this line is negative 1. C. What does this slope tell you about the relationship between lengths and widths of rectangles with perimeter 24? For every unit added to the length, a unit must be removed from the width, and vice versa. Help me disrupt YouTube's algorithm by liking this video, commenting on this video, sharing this video, and subscribing to my channel. Thanks. I appreciate it.